This is Chapter 6, Video Lecture Number 2. Turn to the page in your notes that we did yesterday where it starts with metals. Scroll down to the bottom, and after the transuranium series, we're going to write in the diatomic elements. Di means two, atomic means atoms. The diatomic elements have two atoms per molecule, but they are still considered to be elements. So at this point, we're going to look at the periodic table. So take out your reference table and open up to the periodic table. There are 7 elements that we consider to be diatomics. Starting with number 7, we have nitrogen, oxygen, fluorine, chlorine, bromine, iodine. That takes care of 6. And the 7th one is hydrogen. I call this the 7H club. There's 7 of them. They start with number 7. They look like a 7. And then the 7th one is hydrogen. So in our notes, next to diatomics, we're going to write the 7H club. And we write a diatomic with the symbol of the element in a subscript 2 to show there's 2 atoms found in the one molecule. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then the 7th member is hydrogen. So we'll look more at how these form when we get to bonding, but for now you have to be able to identify the 7H club. So if we scroll ahead in the notes, past the worksheets, and organizing the elements by electron configuration. Of the 3 major particles, subatomic particles, it's the electron that determines the chemical properties of an element. So there has to be a relationship between the valence electrons of the elements and where they're placed in the periodic table. So we classify the elements into 3 categories. The first is called the representative elements. These are groups 1 and 2, and then 13 through 18. So not the middle section where the transition metals are. The group number tells us the number of valence electrons. So this is all stuff we've done before. And these valence electrons are found in the outermost principal energy level, or a shell. So lithium, group 1, has 1 valence electron, and its electron configuration is 2-1. You should check these out. Sodium also has 1 valence electron. It's also found in group 1. Its configuration is 2-8-1. So it has 1 valence electron and 10 electrons found in the kernel. Carbon has 4 valence electrons, like germanium. They're both found in group 14. Carbon is 2-4. Germanium, you should look, is 2-8-18-4. So they each have 4 valence electrons. Neon is in group 18. Krypton is in group 18. So we should see they each have 8 valence electrons, although their kernel looks different. The transition metals are group 3 through 12. These are the lower part of the periodic table. Titanium, we can see, has 2 valence electrons. Its configuration is 2-8-10-2. Copper, 1 valence electron, configuration of 2-8-18-2. 18, 1. And then we have the intertransition elements, the bottom two rows, which we don't really worry about. So if we move ahead to the next page, we see we have a periodic table arranged by electron dot structures. And the question asks, how does the number of valence electrons vary within a group? A group is a vertical column, and we see, for the most part, the valence electrons remains the same. So group 16 has 6 valence electrons. Group 18 has 8 valence electrons, except for helium, which only has 2 valence electrons. These are called the representative elements, 1 through 2, 13 through 18. And I believe that is it for today. So we shall see you in class tomorrow. Have a great day.